Hello, my people. How are you doing? I hope you are doing fine. All right. So I just want us to quickly go through the assignments sent to us from the maths department, which we are to submit next week, if I'm not mistaken. Yeah. So a whole lot of people have actually reached out to me that how are we going to go about this question because of maybe the typos in the question. So because of that, I would like us not to do with the options in the question. So we will just solve the question here, we get our answer. So when we get our answer, you can actually check if our answer is now in the option. But if it is not there, I want you to be rest assured that the answer we got here is 90% correct. Yes, 90% correct. So let's dive into the question. This is the number one question. This one is talking about limit of a function. So we have find the limit of the function x squared minus 4 divided by what? X minus 2 as x tends to 2. So very fast, this is a fair question, it's not that hard question, but I want us to understand that we have methods of solving this limit of function. We have methods, and we have the direct substitution method, and we have the Alita's rule and the L'Hospital rule. Yeah. So which one are we going to use? According to the rule, let's just follow the direct substitution. Let's see what we have, then we use the other method and see if we are going to get something achievable. So let's start very quickly. So we have the limit of this function. We can now say by direct substitution, by direct substitution. What does that mean? By direct substitution, we'll be having limit as x tends to 2 to be equal to be what? X squared minus 4 all over x minus 2. It means that everywhere we see x, put 2. So we'll be having 2 raised to power 2 minus 4 over 2 minus 2. So what does this mean? It means that we are having 4 minus 4 all over 2 minus 2, which is equal to 0 over 0. And in calculus, when we are taking limits, we say 0 over 0 is indeterminate. Indeterminate. Yes. But you notice that when we are talking about limits, there are some functions, especially when we have ratio, when we have numerator and denominator. There are some functions that until when we factorize or use L'Hospital rule, until when we do that, we get our actual limit. I get what I'm saying. So what are we going to do next? We are going to use the second rule, which means we can actually factorize. But before then, you will notice that at this numerator, we are having x squared minus 4. X squared minus 4. When we go back to our secondary school level, we know that these values we have here, it is what we call the difference of two squares. When we have, don't forget that when we have a squared minus b squared, it is what? A minus b into bracket a plus b. Yes, so this is what we are going to be using. Difference of two squares. So we change this numerator to what? Difference of two squares. And when we change it to difference of two squares, what do we have? It means we will now be having limit as x tends to what? 2. Now I hope you are seeing it. As x tends to 2. Let me make my writing bigger a little bit. We'll be having x squared minus 4 all over x minus 2. It means I will now be having x minus 2 into bracket x plus 2 all over x minus 2. I just put it in brackets. I just put the numerator in brackets. So what do we have? You can now see that this one will knock this one out. So instead of me writing all of this as a function, I will not be doing that again. I will just pick this one. So it means that I'm now looking for the limit of x plus 2 as x tends to 2. What does this mean? It means that I'm now saying that x is what? 2 plus 2. Then our limit is equals to 4. Very easy. So the actual limit of this function is what? 4. When x tends to 2. So it is as simple as that. So what do we do? Let me just take a quick recap. What we do is that we first use our direct substitution. We notice that we have 0 over 0. Whenever we have 0 over 0, or any number divided by 0, the limit is what? Undefined. But we in mathematics, we don't actually accept that the limit of any function is undefined, except we have actually applied some other method of solving it before we accept. Yes. So we now use what? We now use the Alita's rule, which says that we can actually factorize. So when we factorize, we later it out. We have what? X minus 2, x plus 2, divided by what? X minus 2. This one can take care of this one, so it is out. Then we have x plus 2 as x tends to 2, to be 2 plus 2, which is equals to 4. It's as simple as that. So this takes care of the number 1 question. So let's quickly move to the number 2 question very fast. Yes. So this is the second question. They said, what is the limit of x plus 1 into bracket 2 plus x all divided by x cubed plus x as x tends to infinity? We all know that when we want to take a limit at infinity, we have a different approach to find limit at infinity. What is the approach? We have to divide through by the what? By the highest power. And from looking at it from here, we can see that for now, x cubed is our highest power. Very good. Let's note that. But we will not do it this way. What are we going to do first? We need to open this bracket and get what is inside before we can now divide through by the highest power. So when we open this bracket, what do we have? When we open the bracket, what do we have? We have 2 plus 3x plus x squared at the numerator all over s cubed plus x. So we have this now. When we have this, what we have, don't forget the rule. Divide through by the highest power. When we divide through by the highest power, what do we have? It means we have 2 over x cubed plus 3x over x cubed plus x squared over x cubed. Everything divided by x cubed over x cubed plus x over x cubed. Don't get it twisted. What do we do here? We just divide the numerator by the highest power and the denominator too by the highest power. What am I talking about? These 2 divided by x cubed, we have it. 3x divided by x cubed, we have it. X squared divided by x cubed, we have it. X cubed divided by x cubed plus x divided by x cubed. That is just what we do. So you will now notice that some of these x will go. 2 divided by x cubed, we still have it to be 2 divided by x cubed plus this will go. We have 3 now over x squared because one of it has gone plus 2 of this will go. We have 1 remaining over 2 of this is gone. We have x over x cubed divided by x cubed. It is 1 plus x divided by x squared. We have 1 over x squared. Now we can now take our limit as x tends to infinity. So when we take our limit as x tends to infinity, what will happen? We have 2 over infinity cube. You know, when we take limit, it means that anywhere we see x, we put infinity plus 3 over infinity squared plus 1 over infinity everything divided by, we have 1 plus 1 over infinity squared. Don't forget that whenever we have infinity as the denominator, it becomes 0. So this becomes 0, this becomes 0, this becomes 0, this becomes 0. So what do we have? At the numerator we have 0 plus 0 plus 0, 0. At the denominator we have 1 plus 0, 1. So our limit as x tends to infinity is 0 question. So you can see we just actually follow the procedure. And what is the procedure? Divide by the highest power. So when we open these brackets, when we expand this numerator, we have this. We can do it. We get this. And when we get this, we divide through by the highest power, which is x cubed. And we have all of this. Then we do our normal division. X divided by x cubed. We have 3 over x squared. So we just do our normal division. Then we take our limit as x tends to infinity. We have all of this, and our answer is equals to 0. So this is the answer for the number 2 question. So we can now move to the number 3 question now very fast. This is the number 3 question. This is the number 3 question, and it is under composite function. Yes. Don't forget that we have fx to be x squared, and we have gx to be 3x minus 2. They said we should find what? G of f at what? 2. Let's just put it that way. So whenever we have questions like this, I have a very simple method of solving. Very, very simple method. It means that g is the owner of the function, and whenever we see x, it is now taking the function of fx. Are you getting what I'm saying? G is the function, but whenever we see x in the function of g, it will now be what? Fx. If I will rewrite this now, it will now be what? 3. Don't forget what I said. Everywhere I see x, I'll be putting fx. 3fx. Are you getting it? Minus 2. It is still saying what? 3x minus 2. 3x minus 2. So you now ask yourself, what is the value of fx? Now, the value of our fx is what? 3x squared. Right? Minus 2. Please, are you getting it? So, now, they now say as what? At 2. It means when x is equals to 2, what is the value? So, at 2, what is the value of that function? It is just 3 into bracket 2 raised to power 2 minus 2. So we have it to do what? 3 times, this becomes 3 times 4, which is 12 minus 2. And this becomes 12 minus 2, which is what? 10. I don't want to elongate it. So our answer for this question is 10. You can check your answer if it is 10. Our answer for this question is 10. Oh, I can see you cannot see it. Yes, you can see it. 12 minus 2, 10. It's as simple as that. So what do we do? Taking fx minus 2. Don't forget I said g is the owner of the function. So we are bringing fx inside. So whenever we see x, replace it with what? Fx. So which means that I'm having 3 into bracket what? What is the value of fx? X squared minus 2. Right? So I'm having 3 into bracket what? 2 raised to power 2, because they say add 2 here from here. So 3 into bracket 2 raised to power 2 minus 2. So it means we have 3 times what? 4 minus 2. 3 times 4 is 12. So 12 minus 2 is 10. It's as simple as, nothing is there. It's as simple as that. So this is our number 3 question, and this is the answer. This is the number 4 question. Now, this number 4 question is just asking us a simple question. They said, is the function fx equals to 1 over x minus 1 continuous at point x equals to 1? Now, this question is under continuity, and we already know when a function is continuous at a point or discontinuous. And we need to even ask ourselves that question before we can answer it. When do we say a function is continuous? When do we say this function is not continuous at a point. Don't forget that when we are talking about continuity, we are talking about it at a particular point in time. I get what I'm saying. Now, which means that when we evaluate this function now at x equals to 1, do we have, please listen, do we have 0 at the denominator? Because we say a function is discontinuous whenever we have 0 as the denominator. We don't care about the numerator. The numerator can be any value. The numerator can be any value, yes. Let's just say any value n. Any value at all, n. But whenever we have n over 0, whenever we have n over 0, it means that function is not continuous at that point. When you press your calculator, 1 divided by 0, it will give you not error. That means it does not have a value. Is too large. I get what I'm saying. So whenever we have n over 0, it means the function is not continuous at that point. Because when we have n over 0, it means infinity. N over 0 means infinity. And when we are plotting our graph, there is no point for infinity on our graph. So it will leave a hole. I guess what I'm saying. Whenever we are plotting a graph, let's say this point now, it is undefined. So there's no value. I cannot get the value here on the graph. Then we cannot continue. So this point here now is a hole, because this point is what? The point of discontinuity. Please, I get what I'm saying. This point is a point of discontinuity. So let's evaluate this function now at x equals to 1. Let's see what we are going to have. So we will not be saying fx again. We now say f into bracket 1. So we'll be having 1 over 1 minus 1. You can see, very simple. 1 over 0. It means it is not continuous because this will give you what? Undefined. This will give you undefined. So it is not continuous. As simple as that. As simple as that. So that's what the question number 4 is talking about. The function is not continuous at x equals to 1 or at that point. As simple as that. So thank you. So let's move on to the next question very fast. Yes, so I think this is number 5 question, yes. And this is one of, I think this is one of the simplest questions out of the numbers of questions that are given to us. They said, find dy dx if y is equals to 5x raised to the power 4. We already know the basic rule for differentiation. And what is the basic rule? It says whenever we have y towards, let's say x raised to the power n, ax raised to the power n, let's say the a is 5, and the x is what we have in, n is 4. Our dy, the x, will be a times what? N times x raised to the power n minus 1. So let's use this to get this answer. Very simple. So now from here now, our dy dx will just be what? What is our a? 5. What's our n now? Our n is into 4. Our n is 4, right? And we have x. Let's go what? 4 minus 1. So as simple as that. Then we have our answer to the what? 5 times 4. 20 x raised to the power 3. This is the answer. This is the answer. Our answer is 20 x raised to the power 3. It's as simple as that. No long term. Except if they say using first principle. But if you are just to apply this normal rule, it's as simple as that. So our answer is 20 x raised to the power 3. It's as simple as that. So this is the number 6 question. I actually thought the number 5 question was the simplest. I don't know that this one is even more easier. So they said find the f prime of x if fx is equal to x squared plus 3x. Now, you now say, okay, what is f prime? F prime is still the same thing as saying the derivative. Okay, if you don't understand the word derivative, it's still the same thing as saying dy dx. So what are they saying? What are they saying here? They just want us to find the what? Dy dx of x squared plus 3x. Very, very simple. So what do? You just say, okay, our f prime now of x will not be, just want to differentiate them. So when we differentiate x squared, what do we have? We have 2x plus, when we differentiate 3x, we have 3. It's as simple as that. This number 6 is very, very simple. So our answer is what? 2x plus 3. It's as simple as that. So let's move on to the next question. We still have some more technical questions in the front. So let's see it. Please, we don't need to waste much of our time. We don't need to waste much of our time. They say find the derivative of the function fx equals to what? X raised to power n at any point x. It's still the same thing. What they are asking us for is to find the dy dx, to find the what? Differentiation. Abi? Yes. So when we have a function like this, I think I just do it in the other question. So it will be what? F prime of x is what? Yes. By the differentiation rule, this n is multiplying x. So we have nx raised to power what? N minus 1. It's as simple as that. So this is the general rule for differentiation of algebra. This is the general rule for differentiation of algebra. So it's as simple as that. There's no need to be wasting our time. So this is the answer. So let's move on to number 8 question very fast. Very quickly, this is our number 8 question. I want to believe everybody should be able to solve this one, because this question is just like one I did the other time, and we have done it over and over. So what do? I want to get our derivative. What's happening? We still follow the rule. It means we are multiplying the variable x by the power, then we subtract 1 from the power. It's as simple as that. So our dy dx is what? Multiplied by the power. We have 8x. Subtract 1 from the power. 8 minus 1. So what do we have? Our dy dx will be what? 8x raised to 7. It's as simple as that. It's as simple as that. Don't waste your time. It's as simple as that. Now, I noticed that in number 9 question, 10, I think 11, they are repetition of number 1, 2, 3. So we will not be doing that again. We just want to move maybe to number 13, I'm not sure. I'm checking now. We just want to move to those parts. So we do it very fast. And I want to, because of the time, I don't want this, what's it called? The lecture to be too long. So I will just stop here. Then we move to the next part in our next class. So thank you for your time. I really appreciate it. So thank you very much. God bless you.